Welcome students. Now this is the lecture number first. Today we will discuss time complexity and space complexity. So here you can see that at first we have written the worst to best cases. So at first we have written order of n factorial, then order of 2 ki power n, then order of n ki power k, then order of n cube, order of n square, order of n, order of log n, and order of 1. So what is this actually? Today we will explain how to find it. So we can have 3 cases to analyze an algorithm. The first one is the worst case, second one is the average case, and third one is the best case. How to find it? So here already if you will search in Google, then you can find the time complexity of best, average and worst case. They have written order of n log n or something, order of n square, order of n plus k, order of nk, something. So how to find it? This is a question. Now how to measure the time and space complexity? This is a question. So here we will not discuss. So now at first, what is the definition? Time complexity. The time complexity of an algorithm quantifies the amount of time taken by an algorithm to run as a function of the length of the input. Note that the time to run is a function of the length of the input and not an actual execution time of the machine on which the algorithm is running on. In order to calculate time complexity on an algorithm, it is assumed that a constant time c is taken to execute one operation and then the total operations for an input length on n are calculated. What is the space complexity? The space complexity of an algorithm quantifies the amount of space taken by an algorithm to run as a function of length of the input. Actually, what is this? We will explain by the help of some example. Okay, so let us at first I will show you whatever we have written by the help of some images. So at first, time complexity. Now here the first example I have written for I is equal to 0, I is less than n, I plus plus. So this count plus plus means this loop is working 0 to n. It means that the count will be execute n times. It means that this count it will execute n times. Similarly, if we will come here, now here in the second example, for I is equal to 0, I is less than n, I plus plus. Then for j is equal to 0, j is less than n, j plus plus. Here you must note, whenever you are writing any loop function, okay, loop, and after then there is another line. So this loop will execute this one line, it can execute. If there are more than one line, then you have to use the curly bracket. Okay, so one line it will execute and after then it will execute. In this condition, you can see that this j totally depend on I. It means that this count will execute n square time because it is working n time, it is working n time. It means that this count will execute n square times. I think that you understand. Now the third one is for I is equal to 0, I is less than n, I plus plus. It means that this count will execute n times. Another for loop in the function j is equal to 0, j is less than n, j plus plus. This count will also execute n times. So this loop, okay, and this loop both are independent. Okay, both loop are independent. In this condition, I and j both are independent. It means that n plus n is equal to 2n. So the total time complexity for such program will be 2n. Now here The fourth example, this is the best example. At first we have written count is equal to 2. Then we are using do while loop. Do while loop printf count. Okay. So count minus minus while count is not equal to 0. So this, it will work. It will work constant time. Maybe we can also replace this value. Okay. In this condition it will be constant time. So here it will work. At first it will print 2, then 1, then after then 0. Means it will print 2 and 1. Okay, 2 times. Otherwise it is constant time if I will change the value. Now here for I is equal to 0, I is less than n, I plus plus. This count will work n times. So execute n times. It means that constant plus variable is equal to again variable. You must understand. Constant means something, anything, 2, 3, 4, 5, and variable means this n. Okay, it's totally depend on n. I can change the value. So if I will write here 10, then this loop will work 10 times. If I will write here 100, then this loop will work 100 times. So this is the variable. Okay, so whenever you will add constant plus variable, so every time you will get variable. Okay, constant plus constant is equal to constant, variable plus variable is equal to variable, constant plus variable is equal to variable. These are the three basic mathematical notations. Means you have to remember constant plus constant is equal to constant, constant plus variable is equal to variable, and variable plus variable is equal to variable. Okay, so now the fifth example, I will show you something. The first one is for I is equal to 0, I is less than n, I plus plus. Then another loop, j is equal to 0, j is less than I, and j plus plus. This time j is less than I and count plus plus. Okay, means I and j both are dependent. Now when I is equal to 0, when I is equal to 0, this loop will work only one time. When I is equal to 1, then this loop will work 2 times. Okay, means one time I is equal to 0, j is equal to 0 and j is equal to 1. Here we have written one time. It will work j is equal to 0, it will work one time. Here we have done some mistake. You have to must write here one time. It will work 2 times, it will work 3 times, up to so on. So means even you will replace this one, no problem. Means 1 plus 2 plus 3. So this is the summation of all natural number, that will be n into n minus 1 or n plus 1 upon 2. That will be order of n square. Means overall you will get here the last one is n minus 1 because this is n. Okay, and it will not work. This loop will work till n minus 1, not n times. Okay, because it is starting from 0, so it will work total n minus 1 time, but it is starting from 0 means total n times. Okay, so here we have written n minus 1 in. Okay, so your total time complexity is order of n square. Now the sixth interesting topic is for I is equal to 1 and I is less than n, I is equal to I into 2. This time in place of I plus plus, I have written I is equal to I into 2. So count plus plus. So now let us n is equal to 10. For I is equal to 0. If I is equal to 0, then 1 is less than n, means 10. 1 is less than 10. It means that this value it will be changed. I is equal to 1 because of I is equal to 1. 1 into 2 is equal to 2 ki power n. 1 we can write. Now you can see that I has been changed because we have written I is equal to I into 2. So I has been changed. It means that second time I is equal to 2. So again the compiler will check 2 is less than n, means 2 is less than 10. Yes, less than 10 means I is equal to I into 2, means I is equal to I was 2, so 2 into 2 is equal to 4. So we can write 2 ki power square. Now I has changed I is equal to 4. Now for I is equal to 4, 4 is less than 10. Okay, because I is less than n. Okay, 4 is less than 10. Again it will work. So I is equal to I into 2 means I is equal to I was 4. I was 4, you can see. 4 into 2 is equal to 8. 8 means 2 ki power 3. Okay, now means now this time I is 8. Okay, I is 8. Now I is 8. 8 is less than 10 because of this. Now I is equal to 8. I was 8, you can see. So 8 into 2 is equal to 16 means 2 की power 4, and because 2 की power 4 is equal to 16 and 16 is not less than 10, it means that the count will work only 4 times. 1 time, 2 time, 3 time, 4 time. You can see that whenever we are changing this, then there is a effect, means it will execute only 4 times. Now the question is, what is the time complexity? If we are writing n is equal to 10, then this count will execute 4 times. If I will write n is equal to 100, then this loop will execute how many times? If I will write n is equal to 1000, then this count will execute how many times? Okay, this is the question. So how to find it? Okay, so now here, so this behavior is actually 2 की power I. Okay, this behavior is just like 2 की power I, because when I am writing I is equal to 1, so this is 2 की power 1. If I am writing I is equal to 2, then this is 2 की power square. Okay, means actually what is happening, this count is working total 4 times, 1, 2, 3, 4. So in this condition we can write 2 की power I. Now after then we have written it is converging to n. Why? Because here I is working until it is near to n. Okay, I is working until it is near to n. Whenever I and n both are equal, after then this count will not execute. So it is totally depend on the conditions. It means that 2i is converging to n. Okay, according to the real analysis, 2i is converging to n. So we can write 2i is equal to n. Okay, in this condition now you can take log here and also here. So let the base is 2. So log base 2 की power I is equal to log 2n. Okay, this is a base, not 2. Log 2 base n. Okay, now you already know that log a base a की power n is equal to, this is a formula, log a base a की power n is equal to n. So by the help of this formula, this is I is equal to log 2 base n. So your I is working log n. Your I is working log n times. It means that the time complexity is order of log n. So this is a way to find the time complexity of such type of problems. So again my request to you that you must note it whenever you have such type of any divide and conquer. Okay, formula means algorithm. So you have to use this order of log n. Now the seventh interesting example, it is for I is equal to n and I is greater than 0 and I is equal to I upon 2. So this time we have changed this one. Now count plus plus. Now the question is, how many times this count plus plus will execute? This is the question. So how to find it? So we will take n is equal to 10. Okay, I will take n can be anything because this is a variable. So n is equal to 10. Now then I is equal to 10, it means that this is 10. Now 10 is greater than 0. Yes, 10 is greater than 0. If it is greater than 0, then you have to write I is equal to I upon 2. So what is I? I is 10. So 10 upon 2 is equal to 5. So this 5 you can write n upon 2. Why? Question, why? Because n is 10. N is 10. So this 10 is n upon 2. You can write n upon 2. Now I am writing this is n upon 2 की power 1. I can write na, no problem. Now once I is equal to 10 upon 2 is equal to 5 means now the value of I has been changed. Why? Before it was 10 and we have the condition is I is equal to I upon 2. In this condition your I has been changed. Now I is equal to 5. Again 5 is greater than 0. Yes means it will work. So I is equal to 5 upon 2. Okay, I is equal to 5 upon 2 because I is 5 and the condition is I is equal to I upon 2. Now, so 5 upon 2 is equal to 2. Why? Because I is integer. Okay, you have to take only the integer. Okay, I is equal to 2. Now, 2 you can write, this is 5. In place of 5, we have written n upon 2. So this n upon 2, in place of 5, you can write n upon 2. Already there is 2. So you can write n upon 2 upon 2. So you can write n upon 2 की power square. I think that you understand. Again, So now I has changed. Again, I is equal to 2. Now for I is equal to 2. Now 2 is greater than 0. Yes, 2 is greater than 0. I is equal to I upon 2. What is I? I is 2. So I is equal to 2 upon 2. I is 2. So I is equal to 2 upon 2. So what was 2? Here, what was 2? I is equal to 2. I have written n upon 2 की power 4. Okay, n upon 2 square, sorry, n upon 2 square. So in place of 2, you can write n upon 2 ka square. So this is already upon 2. Now this is n upon 2 ki power 3. I think that you understand. So you can see that this I is equal to 2 upon 2. Okay, 2 upon 2 means 1. Actually this is 1. 2 upon 2 means 1. So I is equal to 1. When I is 1, now 1 is greater than 0. Yes, I is equal to 1 upon 2. Okay, this condition is correct. It means that this will execute. Okay, I know that I is equal to 1 upon 2. This is the float value. So it will be never stored in I. Okay, so in this condition, but this condition will execute, means count will execute. Count will execute. Count is totally depend on this condition. If this condition fulfill, then the count will execute. So in this condition, so the condition is fulfilled because I is 1 and 1 is greater than 0. So in this condition, your 1 was actually what was 1? 1 was n upon 2 ki power 3. So this is n ki power 2 ki power 3. N upon 2 ki power 3 upon 2. So this is n upon 2 ki power 4. Getting? I think that you understand. Now the stop. It will not work because 1 is greater than 0. Now after then float value, it will not work. Hence, the final result is n upon this is 2 ki power I. Same. And it is converging to 1. Why? This is the condition. Because I is greater than 0. Okay. Whenever this is 1 is greater than 0, and after 1, okay, sorry, after 1, the nearest value is 0. Okay. Whenever there is 0, then it will not work. So if there is 1, then it will work. So it means that this count, it will execute until I is not equal to 1. Okay. Once 1, here the value is 1, then after then this count will not execute. Okay. So it means that your condition will fulfill when you will get 1. So this n upon 2 ki power I is converging to a 1 as I is greater than 0. It will work until I is equal to 1. So now take log both sides. Again same, n upon 2 ki power I. This is n is equal to 2 ki power I. Something you will take log, and at last you will get I is equal to log n. So this is a way to find the time complexity of any problem. Okay. So here in this problem, what we have shown here, you can see. I think that you understand how to find the time complexity. So this is n into log n. Into means this loop and this loop both are dependent. Okay, there are two for loop. Okay, one loop is this and second loop is this, and this loop is working n times and this loop is working log n times. It means that this is divide and conquer, and this loop is both are dependent. Both are dependent. This loop is working log n time and this loop is working n times. So n into n, if both are dependent, you will multiply. Okay, here n plus k, it means that this loop and this loop both are independent, so they have written plus. I think that you understand. N square already we have explained. Okay, so everything we have explained, and if someone has written order of 1, it means that this is a constant. You can also write here order of C. Okay, order of C. So we have covered everything. I think that you understand. If you are facing any problem, then you must discuss us. Thank you so much. This lecture only for the coding purpose. Okay, thank you so much.